Hello, my name is Vincent Kennedy, and this is going to be my submission for part bonus project of the final project for EAS3101 Dr. Ozbay's class. So, to start off this project, you're going to get Fluid Flow Fluent and drag that into the project schematic. Then you're going to click on Geometry and select 3D and change it to 2D. Then you're going to open up Geometry and New Design Modeler Geometry. Oh, there it is, open now. Now you're going to go into Concept and create 3D curve. We're going to add a text file that has the coordinate system for our airfoil. So this is in my downloads, and it's in NACA 2415, which is the airfoil for this project. So just click Open, and then you hit Generate, and then you can hit this to go to the part, and then this to center it. And then you could change the view a bit because this is just annoying. So we have this. We do have to edit this slightly because the text file did not allow me to input a closed loop. I had to change this very tip of this end. It does have a gap here. And so you're just going to have to get concepts, lines from points, click this one, and then control click the other one. And then just click apply and generate. Then we're going to go into concepts, surfaces from edges, and click both of these. Just take a little bit of a patience because this is so small. It is a little wonky. There we are. There we go. Click apply and then generate. Now we have our surface. So we can just click this button right here and we can begin creating our surroundings, our system. So we're just going to hit sketch, sketch modeling, rectangle, and then make a nice rectangle around your airfoil. And then we're going to put the units into millimeters because that's what I used. And then we're going to constrain this, make it symmetric. There we go. And then we can add our tip to this box, arc by 3 points. Click, click, and click. Now this is our bounding box. We need to make this very large, so we just make those. And we just change these from this to 15,000 millimeters on the height and width. We can zoom out using our modify tool. We can trim these inner lines. We don't need them. And then we just have to create a concept, surfaces from sketches. Click one of these lines and click apply and hit generate. Now we have this. Now we need to cut out the airfoil from this shape. So you click create, Boolean, unite. You can change that to subtract. Select the large face and apply. And then you can zoom in to your airfoil. Click this, then click the blue line, and click apply, and then hit generate, and this gets cut out very nicely. So now we can create a second sketch. Sketching, we're going to be using the line. So you zoom in, click the origin, and make a horizontal line here, and make 2 vertical lines. Now we can dimension these lines horizontal from the origin. The one inside the airfoil will be 80 millimeters away, and the one outside of the airfoil, cancel that, just needs to be 1,000 millimeters away. So it's on the tip of the tail. So if we zoom in, it should be right at the end of the point. That's very important for the meshing later on. So now we just need to extend these lines to the edges of our system. Extend tool. Click these lines twice. Extend them in both directions. And then we can use the tools face split. Just click the large face, click apply, and then geometry, click our edge select instead of point select, and then select all three lines. Click apply, then click generate. And then if you click the face select and then try and select each face, you get 6 independent faces. Now we need to fix this up just a tad. So we're going to need to click edge select, and we're going to zoom in at these intersections between the arc and the straight line. We need to fix with the merge tool. So it's automatically on faces, just change that to edges, and then select this and this. Then click here, apply, generate, zoom out again, zoom back in, edges, tools, merge, and then just click this, and click apply. So now we have our two merges done. And so this should be complete for our geometry. So now we can begin sketching. So we just go back into our workbench, update our geometry, and open up the mesh. It will take just a little bit to open up, but it should open up fairly quickly. Should be any second now. NVIDIA should, there it is. Now we can begin our meshing. This mesh is fairly complex, so you're just going to want to follow along. So change our geometry. We're going to suppress this line body just because it's causing problems, and then we're going to insert a sizing mesh. We're going to go to line select and select all these lines here. And we're going to click geometry, apply, element size. We're going to change the number of divisions. We're going to just do 150. That's a good number. Divisions. We're going to change capture curvature to no. That'll be the same for all other sizing meshes. So capture curvature no, behavior to hard. And then we're going to have biases for a couple of these. So we're going to want to make this bias factor 50,000. And then we're going to have to reverse our bias for a couple of these. These three are wrong. So just reverse bias, select, select, and select. Click apply. They should disappear, but they're still there. Now we can insert another sizing mesh, top down for these three lines. Click apply, element size, change to number of divisions to 150. And we're going to do capture curvature to no, soft behavior to hard behavior, and we are going to have a bias for this one as well. Bias factor will only be 300 for this one. And we also see a couple that are wrong, so just click those two, reverse them. Now they're correct. We can open up another sizing mesh. This is for on top of our wing. Just hit apply, element size, number of divisions 150, capture curvature to no, soft behavior to hard behavior, and there's no bias for this one, so we just go right to the next one, insert sizing, click these and zoom in, select the front edges of our aircraft, click apply, element size, number of divisions to 150, capture curvature to no, soft behavior to hard behavior, nothing to change here, and then we're going to insert a face mesh. Select all the faces, click apply, and then go to mesh and hit generate. So should show up everything. We did appear to have a problem here, but let me show you. This does take a little bit of tweaking, so let me show you my one that worked. So I can go to File, Open. Right here. All right. Now we can take a look at the mesh, how it was supposed to turn out if it had meshed correctly. It takes a lot of tweaking and a lot of redoing it, but it worked in the same configuration that I did it last time. So you should end up with something that looks like this. We're mainly focusing around the airfoil up and down, and then to finish off this mesh, you would just click, use a line, select all of these, click N, and then it'll open up name selection. That'll be the inlet. Then you do the same for this edge right here. So just here and here, click N, name this outlet. This is inlet, and then you just have to zoom in, click the top, bottom, front, and back. This is the airfoil. Click N, name it airfoil. Okay, that's all you need to do for the meshing. So now you can just leave the meshing, go back in, and go into setup. And click OK. Double precision in 4 solvable processes. This is important for our viscosity calculations. So you just hit start. This takes a little while to load. Just let it run its course. Just a couple more seconds, and it'll load up. This is what you would see when you load up your process, but there are a couple things you need to change. So the first thing you need to change is go to Models, Viscosity. When you start, this will be at Inviscid or Laminar, so you just go and change this over to Transition SST for equations. We're going to click Capture Curvature and then click OK. Then we're going to go into Materials, Fluid, go into Air. Originally, this is going to be like something like this, and this 8 is going to be like 7995. So we're just going to change these to 1.2 and 1.8. And then click Create and Close. The next thing you're going to do is go into Report Definitions, and actually the next thing we're going to do is go into Reference Values, and then we're going to change this. We're going to have to make sure that this is compute from the inlet. That's very important. Then we can just go and we can make our report definitions. This is where we'll be getting our CD and CL. So click, double click this. You're going to click, I already have them, but let me show you how to get them. Click New, Force Report Drag, and then you're going to name this CD. Click Drag Coefficient, click Airfoil, and then you're going to click OK. Oh, and you're going to have to make sure you have print console selected. This is how you get your CD. So you just hit OK. So I did that. And then do the same for CL. So go, instead of drag, go to lift. So you make a CL, and then select lift coefficient, select airfoil, select print to console, then click OK, then cancel or close. And then once that's all done, we can change our residuals. We want a highly specific, we want a very accurate system. So if I can find, is it monitor? It is in monitor. Click residual. And then this will be, we'll be adding an extra 0 in all of these numbers here. So 0, 0, 0, and so on. But I already did that. So that should be 0.001. Then click OK. And then from here, it's just as simple as putting, oh, we also need to make sure our boundary conditions are correct. Sorry about that. Go to inlet. You're going to want to change this from magnitude and direction to components. And then we're going to, first we're going to look at our 0 degrees angle of attack. So you're going to change your XY to correspond to that 0 degrees angle of attack, and do the same for CD and CL. So click apply and close. Now we're going to go into report definitions, open up CD, change this from 0.9 to 1 and 0. Then click OK. Then do the same, 0 and 1. The same for left. And click OK. So then we're going to go into initialize. We're going to hit initialize. Wait for this to be initialized. Go into run calculations. Type in the number of iterations you want. This can be 100, 300, 200. For mine, I did 300. So just type that in and click calculate. This will run our residual plot. And so we wait a bit. This is our residual plot right here. We wait for this to converge or reach 300 iterations. This usually takes the longest amount of time out of all the processes. So we're just going to let this proceed. Okay, there it is. The calculations are complete. Select OK. And now we can go over here into report definitions and select both CD and CL and click compute. This will output our CD and CL values for this angle of attack right here in the output area, the console. So you would just copy and paste these into your Excel sheet. This is the one for 0 degree angle attack. But then we want to go into graphics and we want to create a contour. So we're going to need both a pressure contour and a velocity contour. So we are already here for our pressure contour. So we're just going to hit save and display. Here is our pressure contour. Simple enough. Then we could do the same for our velocity contour. So just click this, velocity magnitude, and click save and display. Here is our velocity magnitude. So that's all good. So the next thing we have to do is click close. And now we need to see how we switch it up for each angle of attack. So to adjust the system for, let's say, 10 degrees angle of attack, I'll only be doing this once because doing it all 9 times or 10 is a little overwhelming. So we're just going to change it to a 10-degree angle of attack. So looking over at my Excel sheet right here, this is the wrong Excel sheet, my bad. This Excel sheet, it shows your unit vectors and inlet velocities that you need to type in into your inlet velocity, and your lift and drag coefficient unit vectors that are in the report definitions. And then this will be our outputs for each system. So you're going to need to grab all these values every time and then put it into the system. So we're going to use these values for 10 degrees right here. So if I bring this back over to my other screen so I can type it in, we just go into inlet velocity right here, go into X, and we can just type in 14.7723467. And then for Y direction, we just type in 2.6, 2.60341561. Click apply, make sure that I hit apply, close, and then we're going to go into our report definitions, CG, change this X to, this is drag, yes. So we're going to change this drag to 0.9848, 2311. And then change the Y to 0.17, I believe. 0.17356. 104. Click OK, and then do a change for CL as well. So let me type this in: negative 0.17356. 104. These values are also only found, you'll find them using this basic trig with angle of attack as the main factor and your inlet velocity, because we're looking for a 1 million Reynolds number for our wing. You just compute that, and we find that you need a free stream velocity of 15. So we're just using that as our base. So now all of these are changed. So we can go into initialize, click initialize, click OK, let this initialize, and then go into run calculations and click calculate. Again, we're going to have to let this run for just a little second here. All right, there we go. Calculation complete. Now we're going to go back into report definitions. These are already selected. Click compute, then close. Here is our CL and CD values for our 10 degrees angle of attack. We can see that our lift is much higher than it was before. Our drag is also higher than before. So now We have our CL and CD for 10 degrees angle of attack. We also need to find our contours. So we go back into contours, static pressure, save and display. Here we are for our 10-degree angle of attack. And we're also going to need a velocity. Here we are, our velocity contours. And that pretty much concludes what we need to find. So to summarize what you need to do next, you just need to go through each angle of attack from -3 to 21 in intervals of 3. At each angle of attack, you calculate your inlet velocity for your x and y values, your unit vector for lift, and your unit vector for drag. And then type those into your inlet velocity parameter right here and into your report definition CD and CL. And then you go run it for each one of these angles and gather CD and CL. And so you'll end up with something like this. As you've seen before, you'll have this here, here. We can see all the equations above that you need to type in to get these values. Your CL, CD, CL/CD, and you make them into nice graphs here, and then present your contours here. So that's all for this project. I thank you for watching and grading, and I hope you have a great day.